welcome everybody to our session talk, Ephemeral Environments Paradigm powered by Spinnaker. Today we will talk about ephemeral environments, which you may know as preview, dynamic, or PR validation environments. Powered by Spinnaker, how we are using Spinnaker to spawn up the ephemeral environments. What is not included in the title is how we are using this paradigm in Armory to test our release process and validate and ensure the quality of our releases. I'm Christos Arvanitis, and I'm an SRE engineer at Armory.
Hi, my name is Edgar Garcia. I am senior software engineer in Armory. How many of you are familiar with the paradigm of using ephemeral environments in your SDLC? Also, how many of you are familiar or are currently using ephemeral environments as part of your pull request validation? All those questions is something that we are going to just explain how you can empower this using Spinnaker.
So back to me. So let's start by some basic concepts. So what is an ephemeral environment? It's an isolated production replica environment, which is fully automated, and it includes all the underlying infrastructure and third-party services. It has a short time to live, which is hence the ephemeral, right? So, and can be used for automated testing, demos, or POCs, or simply gathering feedback from any team, other teams in your organization, like for brand new product features, etc. So the dynamic nature of the ephemeral environments allow us to run multiple environments with on-demand configuration, but at the same time with less cost than having multiple static environments. In the context of automated testing, an ephemeral environment can be deployed in conjunction with a pull request. A series of tests is executed against it, and once we gather the feedback, is teared down before or after merging your pull request. It's not your typical staging environment where the testing happens after the code is merged and deployed. Here, I guess you will guess the next part, we try to shift left. So in the software development lifecycle, and to gather feedback as soon as the pull request, like during the pull request and before we merge the code. We focus to increase the team collaboration and the development speed, but also the quality of the commit.
Cool. So before going forward on our use case, let's just compare a normal staging environment with an ephemeral one using examples. So here's a basic example of how a staging environment looks like. The basic flow of a developer team is that every developer works in their features independently, and they deploy their changes in a staging environment. Every new feature that is deployed one by one in the staging environment has its own environment configuration and limited production data. Once the feature is deployed, we used to run a series of tests to validate the functionality is not broken. And one of the things that I would like to highlight on this is that we used to have like a queue of changes. So most of the time, when there is a lot of changes that we want to prove, we used to have a queue that is waiting for the staging environment to be available. In this other example, this is for using ephemeral environments. In this case, we have the same developers team with their features, but we have an environment factory. The environment factory is responsible on create a temporal environment based on an environment configuration, and it will load test definitions on it. The feature is developed. The feature of the developer is deployed as well as part of the ephemeral environment creation. Once the environment is ready, the automated test will run to validate the functionality, and after that, the environment factory will destroy the ephemeral environment. As we can see in this diagram, we might have multiple environments running at the same time for validating different features in all this validation process. Now let's talk a little bit about our use case in Armory. In our release process for Armory Spinnaker platform, we have a few points to cover that are interested in all this process. We need to validate functionality with multiple cloud providers across the platform as a CI/CD schema. Also support open source Spinnaker changes that comes through our platform. As we support multiple branches for the open source and the Armory ones, we require dynamic configuration for those. And on failures, we want to easily reproduce the issue with a correct version of Spinnaker that is throwing errors in as part of our process. And of course, we want to support and validate Spinnaker plugins in all this process. Now that we know a little bit more about our challenges that we have in the release process, so let's talk about a little bit a solution overview on all this. In the first layer, we have the GitHub Actions. So as we want to validate the platform in a pull request level, we will have a GitHub action that will send a signal to create and destroy the ephemeral environment. So at the end, this is going to be a custom GitHub action that is only like orchestrating when a validation needs to happen in all this like a process, validation process. The next layer would be the control plane Spinnaker. We have a Spinnaker to help us provisioning infrastructure for the ephemeral environment, for the ephemeral Spinnaker, deploy it, and load the end-to-end test in the ephemeral Spinnaker. Also, the control plane would be responsible on destroy the ephemeral Spinnaker deployment and tear down any infrastructure that was created as part of this validation. Finally, the last layer would be the ephemeral Spinnakers. Those ephemeral Spinnakers will be created with pipelines, and the execution for those pipelines will be notified in the pull request that starts the process. In this way, we have a big picture on how the GitHub action and the Spinnaker itself works together to validate the functionality across the releases. Another key piece here is the open source Spinnaker. It is composed by multiple repositories like Cloud Driver, Orca, Fiat, and so on. And the Armory Spinnaker platform is composed by extension projects and Spinnaker plugins. So in Armory, we have an in-home service that is responsible on watching the changes for the open source Spinnaker repositories, the Armory extension projects, and also the Spinnaker plugins. Once there is a new change in all those repositories, we open a pull request to our Armory Stack repository. The Armory Stack repository contains a stack file. The stack file is a representation of a bill of materials, but using the benefits that we have on using a version control system. In this way, every time that there is a new change for any of the services that compose the Armory Spinnaker platform, we open a pull request with the new version that we want to start testing and validating. In the GitHub action layer, the GitHub action is a simple action that triggers all the flow. Every time there is a new pull request, the action checks out the stack, then it triggers the create ephemeral Spinnaker pipeline in our control plane and pass all the information about the stack to just deploy the Spinnaker in the same version that is at top of our pull request. The GitHub action keeps watching the execution for the Spinnaker pipeline to wait for the resolution for the end-to-end test that is going to run in the control plane. And finally, the GitHub action destroys the ephemeral Spinnaker that was created as part of this process when all the tests run and all the validations happens correctly.
So yeah, and Edgar mentioned a big part of the solution is the control plane. The responsibility of this layer is to reliably orchestrate the deployment and the destroy of the ephemeral environments. Moving to the requirements that we have for these ephemeral environments is that they should be production-grade environments, like including all the underlying infrastructure. Any third-party services like Jenkins or a Prometheus server should be part of the creation of each environment. We need to run multiple environments in parallel and in isolation using the same manifest definitions. At the same time, every generated environment should be shareable and accessible within our company. Spawning and destroying every environment should be reliable and triggered either via an automated way or manually. Our control plane is nothing else but our internal production Spinnaker. The whole process is defined in a single ephemeral environment repository where we store our pipelines as code, the definitions for the pipelines for the creation and the destroy of the ephemeral environments. Also, we are storing all the manifests for the application stack and the third-party services. We store the infrastructure as code for all the shared and the dedicated per environment resources. We are also store the test suits definitions, again using pipelines as code and documentation around that. So as we need every environment to be fully dynamic and created, we are templating our manifest using customize without an explicit reference to any configuration. During the deploy stages, the Spinnaker is evaluating the variables, and based on the received artifacts and other parameters, it is deploying for us an ephemeral environment. So yeah, as we mentioned before, we are provisioning multiple environments in parallel. So every environment is deployed to its dedicated namespace. We are deploying MySQL, Redis as persistent stores and also an S3 bucket. We are deploying an OPA server to test any of our policy engine features with some predefined policies. We are also deploying a Jenkins server with preloaded C jobs, a Prometheus server to test the automatic canary analysis. We are also creating IAM policies and roles in the target AWS account for each environment, so we are able to test AWS, ECS, and Lambda plugin functionality. We are also deploying some Kubernetes resources, and we are enabled the Kubernetes provider and the Armory agent as well to test our Kubernetes functionality in Spinnaker. Last but not least, we are deploying the full stack of an Armory environment integrated with all the above and ready to be used as the system under test. All right, so we will jump into some demos right now, and hopefully everything will go away. All right.
Okay, so for this demo, I am going to just show how this is working end-to-end. So in this example, this is a pull request that is just, it was created because there is a new version of the platform. And we have here a GitHub action that is in charge of creating and destroying the ephemeral environment. So just to prove this, if I execute or run this job, this is going to start all the validation process that we already explained. So the GitHub action is going to check out the project, review all the artifacts and the definitions that the stack has at the front of the pull request, and then it's going to send a signal to the control plane or Spinnaker to just create and spin up an ephemeral environment. Then is going to create all the infrastructure and everything that is required by the ephemeral environment just to start the testing. But seems like GitHub Actions is failing.
Yeah, let's wait for GitHub to wake up for now, and we will move to the next demo. All right, so as we mentioned at the beginning, we are using the ephemeral environments not just for automated testing, we are using them across multiple teams. Our technical writers are using ephemeral environments to write up documentation. Our sales engineers are using ephemeral environments to do demos and POCs. Our team is using them for debugging any issues that we are might or might not facing with a customer or a release. So in order to do that, we needed to find a way to scale the usage of the ephemeral environments. If the pipeline is too complex and to be created by any end user, we will get pushback. It will be very hard to onboard new teams and really this paradigm of the ephemeral environments to take off in our organization. So what we have done is we have verified pipelines, and these are the pipelines that we have created. They are verified. We are doing all the changes. And these are the pipelines to basically create and destroy an ephemeral environment. And once we want to abort any of the teams, basically there is a simple PR, a simple pull request. This is a pipeline as code definition, and as you can see, I'm raising this PR to onboard a new application, Spinnaker in the ephemeral environments. Simple definition to deploy and then destroy with some predefined parameters. So I will go ahead and merge this PR, and we can jump into the control plane Spinnaker and see the actual creation. So, all right. As you can see here, the pipeline as code has been rendered correctly, right? And if I search for the summit, here it is the new application that we created, two pipelines to create and destroy an ephemeral environment. So simple as that, a new team can onboard their engineers to the use of the ephemeral environments. And keep in mind that this pipeline might seem complex, but actually it's not. It's basic input, process, output, and we move to the next stage. And at the end of the pipeline, when the pipeline completes, we have an ephemeral Spinnaker and an ephemeral Armory platform. So let's see if the GitHub actually has woken up. I don't see it. I can try to refresh. Ah, yeah. Whatever. Okay. Back to it.
Okay, so moving back again to my demo. Now that the action is running, basically the most important part in all these steps is checking out the artifacts ID for all the stack that we want to test. And then it sends or it triggers the ephemeral Spinnaker in the control plane. So this action is actually leveraged all the responsibility to the control plane, passing all the information about what Spinnaker or what versions of all the services needs to be deployed. So if we go what is that? Yeah, so as you can see, this is a pipeline that is executed by the control plane, by the GitHub action, and is creating all the infrastructure, also is deploying the tools around Spinnaker that is required by the test, like MySQL, Redis, also is deploying an ephemeral Jenkins that is going to be used as part of the testing. Is going to deploy Spinnaker, and finally is going to load all the end-to-end tests that we would like to run as part of this change. So this is something, execution that it used to take a few minutes to execute. So I already have an environment here that is an ephemeral environment. And if we take a look at this application, we can find all the pipelines or the end-to-end tests that we load by default or as part of this process. So basically, we are using pipelines in Spinnaker to just verify and validate all the functionality is working correctly. And this ephemeral Spinnaker is responsible on delivering the execution statuses for each test in the pull request. So at the end, we can end with a pull request, for example, this one, that has all the executions and the tests that pass or not in all this process. So all these statuses are delivered by the ephemeral Spinnaker. So in this way, we can validate and review with immediately feedback if a test pass or not, and what changes or what tests we are just running as part of this change. So, yeah, that's all I have for my demo. So, any questions? Yeah. Okay. Thank you very much.